Welcome to CalcPath Geometry. The lesson that we're looking at today is the application of quadrilateral properties and definitions to solve problems. The key part of this lesson is for you to use the definition and properties of the parallelogram to set up equations and solve problems. So when you're looking at the picture, you need to ask yourself, what do you know about the opposite sides or the opposite angles, the consecutive angles, the diagonals? If you know the properties of the shape, they will help you know what types of equations to build to help you solve the problems. In application example 1 for the parallelogram, we're looking at parallelogram CDEF, where DE, the full length, is 74, DG, this little piece, is 31 millimeters, and angle FCD, FCD being the whole angle, is 42 degrees. They asked us to find the length of CF. CF is the opposite side. Opposite sides of a parallelogram are congruent, so this is also 74 millimeters. They asked us to find the measure of angle EFC. EFC is this angle. For a parallelogram, we know that opposite angles are congruent, but consecutive angles are supplementary. So 42 plus angle ECF adds to 180. If you take away 42 from 180, you get 138 degrees. And lastly, for this particular application problem, they want us to find the length of DF, which is the diagonal. The diagonals of a parallelogram don't do very much, but as we saw in our exploration, they do bisect each other. So this piece is also 31, making the full length of DF 31 plus 31, or 62. Application problem 2 for parallelograms. Parallelogram KLMN is given with the following lengths. LM is 28 inches. LN, which is a diagonal, is 26 inches. And LKN, the whole angle, is 74 degrees. Finding KN is the opposite of the 28, so that's 28 inches. Angle NML is the opposite angle on a parallelogram. Opposite angles are congruent. And side segment LO. Well, LO is half of the diagonal, because the diagonal is bisected. Half of 26 is 13 inches. Additional applications of parallelograms. For this video clip, the next clip will have rectangle, rhombus, and square. For this video clip, we're looking at this. Given that this is a parallelogram, it should have said that that was given. We know the opposite sides are equal, so we can set that equation equal. Subtract 6a away from both sides, add 4 to both sides. 14 equals 2a. Divide by 2, a equals 7. They didn't say what they wanted us to solve for. We might have to plug it back in if they asked for side lengths. They did not, that I know of, so I'm just solving for the variables now. We have angle W and angle Z. They are not opposite angles, so I will not set them equal. In a parallelogram, consecutive angles are supplementary. So I know that 18b minus 11 plus 9b plus 2 is equal to 180 degrees because consecutive angles are supplementary. This means that 27b minus 9 equals 180. When I add 9 to 180, I have 189 divided by 27. So b is 7. Once again, if I wanted to find the angles, if I were asked for the specific angles or sides, I would plug these values back in. In our next problem, we have two variables. It looks like we might have a two-variable system, but not necessarily. We know that the diagonals, that's what those things are pieces of, are bisected in every parallelogram. So we know that 4z minus 9 has to be the exact same length as 2z. We know that these two lengths are also congruent. They're different from the short diagonal. They're a longer diagonal. But 3w equals w plus 8. So we solve, we get 2w equals 8. In this case, w equals 4. Here we subtract, we add 9 to both sides and subtract 2z. 2z equals 9. So z equals 4.5. They do ask us, apparently I wasn't reading below, they asked us to find the length of yz. The length of yz would be 8 times a, which would be 56, minus 4 would be 52. For the measure of angle z, we plug in the value of b. We had found b to be 7. 9 times 7 plus 2 is 65 degrees. Then we have, on this one, finding gj, or jg, w plus 8. W is 4. 4 plus 8 is 12. Finding FH. FH is the full length, so we're going to plug in z. 4 times 4.5 minus 9 is 9. 2 times 4.5 is 9, so each of those is 9. This is a total length of 18. Please look at the very next clip for examples of how to use application problems for the properties of rectangles, rhombuses, and squares.